You ever look at the language of advanced research and just your eyes glaze over? It feels like you're staring at a wall of code that's impossible to crack. Well, today, we're going to take a journey behind that wall. We're going to decode that language and find the incredible stories and ideas hiding in plain sight. So let's get into it.
Okay, so you see a title like this one, Recent Progress in the Theory of the Euler and Navier-Stokes Equations, right?
And then this one hits you, non-associative normed algebras.
Or how about this beast, non-commutative mathematics for quantum systems?
And just to top it all off, orthogonal polynomials and Painavez equations.
Okay. Whew. It's a lot, isn't it? It is so easy to feel completely overwhelmed. What does any of this even mean? Is it all just word salad designed to make our head spin?
But here's the thing. What if it's not a wall at all? What if we just need to change how we're looking at it? Let's try to reframe this. It's not a wall of jargon, it's a map of the unknown.
And that's really the key here. These aren't just random words thrown together. Every single title is a signpost, and it's deliberately pointing the way to a whole new world of ideas. And if we start looking at the map they create, we can actually begin to see some incredible patterns, these huge themes that connect all of these seemingly separate fields. So our first major landmark on this map, we'll call it the logic of chance. This is all about exploring the absolutely fascinating world of unpredictability, from the tiniest quantum particles all the way up to the entire cosmos.
And check out the scale of this idea. On the left, you've got quantum stochastics, which is trying to get a handle on randomness in the super weird world of subatomic particles. And then on the right, you have non-homogeneous random walks, which is modeling unpredictable paths on a much, much bigger scale. It's the exact same core idea, the mathematics of chance, just playing out in two totally different universes.
Okay, so we keep seeing that word stochastic. It's popping up all over. So let's just pause for a second. What exactly is a stochastic system?
To put it simply, it's any system where randomness plays a part in how it develops over time. Think about the stock market, or the weather, or even just a little piece of dust floating in a sunbeam. It's the mathematical toolkit we use for any journey where we kind of know the general direction, but we can never ever predict the very next step for sure.
And that leads us to our next big stop on the map, the shape of ideas. Now this is where things get really, really creative. This is where we see how mathematicians literally build entire worlds with their own rules, their own laws of physics, their own geometries, all using what they call abstract structures. And the core concept here is something called a mathematical space. Now, when a researcher says space, they're not necessarily talking about outer space or the room you're in. They mean any collection of things. It could be numbers, functions, data points, anything that are all connected by a specific set of rules. It's kind of like being an architect for reality itself. And these spaces can look wildly different. Over on the left, you have something called geometry in a Fréchet context, which explores these totally mind-bending, infinite-dimensional spaces. But then on the right, you have functional data structures, which is all about the space of information itself, figuring out the best shape to organize data for a computer. They're both about navigating worlds built from pure logic, they just have very different rules of the road. And the exploration, it just goes on and on. There are Sobolev spaces, which are absolutely essential for solving certain types of equations, and Banach spaces, which give us a whole framework for studying functions. Every single one of these strange names represents a unique intellectual landscape, a new world with its own puzzles and discoveries, all being mapped out piece by piece.
Okay, I can practically hear you thinking it. This is fascinating, I guess, but what's the point? Why are we mapping these bizarre, abstract worlds? And that, my friends, brings us to the most important connection of all. This is where we go from the abstract to the actual, and see how these pure ideas power the world we live in.
Let's take a perfect example, this field called wavelets. The journey from this pure idea all the way to your pocket is honestly astounding. So a wavelet is basically a mathematical microscope for breaking down a signal, like an image, into its most basic parts. It starts as a totally abstract idea. That idea leads to some really powerful formulas. Then engineers take those formulas and turn them into compression algorithms, like the one that powers JPEG 2000. And that algorithm is the reason you can store thousands of high-quality photos on your phone. See that? Pure idea to your pocket. That's the pipeline of innovation. And this isn't just a fluke. This pipeline is happening everywhere. These abstract fields, things like matrix analysis and probability theory, they are the invisible engines running so much of our modern technology. The very same probability theory that helps a financial model guess what the market will do is the same fundamental logic that helps a medical scanner tell the difference between healthy and unhealthy tissue. It's wild.
So, after decoding some of these titles and seeing all these connections, where does that leave us? Well, it leaves us looking out at this incredible, unending horizon, this deep, fundamental human quest to simply understand things.
Those book covers from the beginning, they don't seem so intimidating anymore, do they? Now we can see them for what they really are. They aren't a wall. They're monuments to human curiosity. Every single one is a dispatch sent back from the very edge of the known universe, like a postcard from the frontier of thought.
And what's really exciting is that the abstract research happening right now in fields with names we might not even get yet is laying the foundation for the technologies of tomorrow. We're talking about things that sound like pure science fiction, like sustainable interactive wireless stickers, and countless other innovations we can't even begin to imagine. And that's the beautiful, thrilling reality of it all. Knowledge is a frontier that has no end. The map just keeps getting bigger. Which leaves us with one final, inspiring question. What on earth are we going to discover next?